Hello everyone, hope you're all doing well, having a great time and of course staying safe. This is the last part of this chapter. So in this chapter we will try to talk about nuclear fusion, and by the end of this lesson you will have to know the difference between nuclear fission and nuclear fusion. Okay, let's start. So in the previous lesson we talked about what is the difference, what is the disadvantage and advantage of fission, and what are the waste, the possible waste that comes out of that process. And in this lesson we will try to understand what is the difference between fossil fuel, the use of fossil fuel, and nuclear energy. As you can see the title, nuclear fuel versus fossil fuel. So the first thing is their building. You know that nuclear power plant costs more to build because of the safety measurement and all that. So building a nuclear power plant will cost more than a power plant for that actually is used for fossil fuel. But nuclear power plant often costs less to run. So it takes a lot of money to build, but it takes less money to manage it or run it.
کاتۆکو وتمان نرخی دروستکردنی وێزگەیەکە بۆ وزەی ناوەکی بشێ زۆر زیاترە وەک لە نرخی دروستکردنی وێزگەیەک کە بۆ فۆسل فیول دروستکراوە. بەڵام ئیشپێکردنی وێزگەیەکی وزەی ناوەکی کەمتری دێچێ لە ئیشپێکردنی وێزگەیە کە سوتەمەنی فۆسل فیول بەکاربێنە.
Let's talk about their waste. First, the nuclear power plant do not release any kind of gases. So nuclear power plant do not release gases. Now, one of those gases is carbon dioxide. Obviously, carbon dioxide is a byproduct of fossil fuel use. You can ask me, what about those white smoke that comes out from that nuclear power plant? In that case, my answer would be the following. That is not carbon dioxide or any other kind of gas. It is actually steam. So once again, remember, nuclear power plants do not release gases such as carbon dioxide into the atmosphere, so they don't pollute the atmosphere. The use of nuclear fission allows our supply of fossil fuel to last longer. Now, let me ask you a question. Why it is important for fossil fuel to last longer? The answer is very, very simple. Fossil fuel is not renewable kind of fuel. So once it is gone, it is gone. You cannot make it once again. Why people use fossil fuel? Because we didn't have any other source of energy. Now imagine nowadays we have another source of energy, which is nuclear energy. So using a nuclear energy made many countries to use less fossil fuel. پێم وابێ ئەم بەشیان ئاسانە. So وێزگەناوەکیەکان گازی دوانۆکسیدی کاربۆن دەرناپەڕێنە ناو هەواوە. هەروەها nuclear fission وامان لێیەکە کەمتر fossil fuel بەکاربێنین. ئەمەش دەبێتە هۆی چی؟ ئەوە fossil fuel بۆ ماوەیەکی دوور و درێژتر بمێنێتەوە. Let's talk about another type of nuclear reaction, which is nuclear fusion. Nuclear fusion is another nuclear reaction in which matter is converted into energy. So what is nuclear fusion? Nuclear fusion is the combination of nuclei of a small atom to form a large nucleus. It releases energy. In a nuclear fusion, two or more nuclei that have small mass combine or fuse
to form a larger nucleus. Let's talk about the example that is in front of you, the picture in front of you. Now, this is an example of proton-proton fusion. 4 hydrogen atoms are fused into a single helium atom, release a lot of energy in the process. Now, that is very simple explanation of this process, but in detail, if we talked about this process in detail, in the proton-proton fusion, or in the picture in front of you, what happens is the first 2 proton or 2 hydrogens fuse. Usually they break apart again immediately, but once in a while, one of the protons is transmitted into a neutron. The resulting proton-neutron pair is a type of hydrogen, which is deuterium. Now another proton collide with the deuterium nucleus, forming a helium-3 nucleus. 2 protons and neutron, plus a gamma ray, of course. 2 helium-3 nuclei collide. A helium-4 nucleus is created, plus 2 extra protons. This is the explanation of this picture and the whole process in detail, but in your book it only says 2 or more nuclei have the small mass combine or fuse to form a large nucleus. And even in the picture in your book, you have 4 hydrogen that combine, make a lot of energy, helium, and 2 beta particles or 2 positrons. Keep in your mind that in order for fusion to happen, the repulsion between positively charged nucleus must be overcome. Now, whenever the 2 particles have different charge, they attract each other. Well, what happens if 2 particles have the same charge? They repulse each other. In order to overcome this, you need a very high temperature, almost 100 million degrees Celsius. At this temperature, matter is plasma. So what is plasma? A plasma is a state of matter which is made up of ions and electrons. The only place with that temperature is the sun's core. So if we heat a gas to high temperature, it becomes plasma, as you can see in the picture in front of you. We already said that the place for nuclear fusion to happen or take place is the sun's core. Imagine the only place that has such a temperature for nuclear fusion is the sun's core. In sun's core, what happens is that the hydrogen nuclei fuses to form a helium nucleus, as you can see in the picture in front of you. You already know that the sun is a gigantic ball of hydrogen. It is a star, so it is made of gas. And sun is made of hydrogen. Inside the sun, the hydrogen atoms are heated so much they turn into a plasma state, where electrons no longer orbit the protons in the atom nuclei. The freed nuclei then fuse to form helium atom and neutron. This fusion process unleashes a vast burst of energy, or you can say it releases a lot of energy. Moving on to the advantage and disadvantage of a fusion. So the first thing that comes to our mind is electricity cannot be generated by using nuclear fusion. Now the question is why? Why we cannot make energy out of fusion? Because more energy is needed to hold the plasma than it is generated by fusion. Imagine you need more energy to hold the plasma state. But still, scientists predict that fusion will provide electrical energy in the future. کەواتە وەکوتمان وزەی ناتوانین وزەی ماڵان کارەبای ماڵانی پێ بەرهەم بێنین بۆ لەبەرەوەی فیوژن پێویستی بە بڕێکی زۆر گەورەیە لە وزە بۆ مانەوەیان پارێزگاریکردن لە باری پلازما تێگەیشتن لەبەرەوە ناتوانین وزەی کارەبای پێ بەرهەم بهێنین بۆ ماڵان.
What about their waste? The product of fusion reaction are not radioactive.
کەواتە پرۆدەکتی fusion reaction تیشکدەر نین.
So we can say that fusion is a cleaner source of energy than fission is.
بەم شێوەیەش ئەتوانین بڵێین fusion سەرچاوێکی وزەی پاکترە وەک لە fission.
So in the process of fusion, we would have much less radioactive waste. But scientists need to do a lot of research. You know that. They need to do a lot of work to reach that point. So a lot of money need to be paid for research.
The second one, oceans of fuel. Scientists use hydrogen 2 and hydrogen 3 in their work when they work on fusion. Although hydrogen 1 is much more common than these two isotopes,
there is enough of them in the Earth's water to provide fuel for millions of years.
So remember, hydrogen 2 and 3, they exist in water. And you know we have a lot of water on Earth's surface. And of course, this means that we have a lot of fuel.
What about the amount of energy that is released by the process of fusion or fusion reaction? The energy that is released by the process of fusion reaction is much more than the energy that is released by the process of fission reaction.
Also, fusion saves more transitional energy resources than fission. Moving on to the accident. You remember that when we use nuclear energy, a lot of accident happens. For example, Chernobyl. The concern about an accident such as what happened in Chernobyl is much lower for fusion reaction. If fusion reactor explode, very little radioactive material would be released because fusion products are not radioactive. What about hydrogen 3? Hydrogen 3 used for fuel in fusion reaction or reactors is much less radioactive than uranium used in fission reactors. But you will also have to know another thing. The explosion that happens because of hydrogen bomb, or if an fusion reactor exploded, the amount of energy in this case would be much more than a fission reactor or a uranium bomb. Okay, we reached the end of this lesson, so thank you for your time, and of course, thank you for your attention. Your homework will be the chapter review in page 272. Now, I asked you another question, and I think it is very easy one for you to answer. The question says, which one of them is more devastating, nuclear bomb or hydrogen bomb? And why?
So that's your homework to do, and good luck.